Section 4.4 exercises. Problem 1. We're asked to solve the given exponential function. Here what we'll do is use the property if we have a number raised to a power and on the other side we have the same base raised to a different power, then we can immediately conclude that the exponents must be the same. So the idea is to get each side written as the same base. So on the left, we'll write 5 to the 3x minus 6 as given. And on the right side, we'll rewrite 125 as 5 to the third power. That means that we can now make an equation out of the exponents. So 3x minus 6 will be equal to 3. And solving for x then, we'll have 3x is equal to 9, giving x is equal to 3. And that is the solution to problem 1. Go to problem 2. Solve this exponential. Here we have to write both sides with the same base. So we'll choose a base of 2. 8 is 2 to the third power. So we have 8 raised to the x plus 2 power. And on the other side, we will write 4 as 2 squared. And 4 is raised to the x minus 3 power. Now we use a rule of exponents that power to power multiplies. So we'll have 2 to the power 3 times x plus 2. And on the right side, 2 to the power 2 times x minus 3. Now that we have the bases the same on both sides, we can now make an equation out of the exponents. So 3 times x plus 2 must be equal to 2 times x minus 3. So we'll distribute on the left and the right. 3x plus 6 is equal to 2x minus 6. And rearranging the equation to isolate the x, we'll have 3x minus 2x equals negative 6. We'll bring the other 6 to the other side. That'll give us positive x is equal to negative 12, which is the solution to problem 2. Let's move on to problem number 3. Here, it is not possible in problem number 2 to solve the exponential by writing both sides with the same base. So what we'll have to do is use logarithms. We'll take the common log of both sides. Now, any logarithm with any base can be chosen, but since we have 10 to the power, we'll choose the common log, which is base 10. Now we use property of logarithms that the exponent becomes the multiplier. So we have x log 10 equals log of 8,000. And log base 10 of 10 means 10 to what power is 10, and that is 1. So we get x by itself then is equal to the log of 8,000. And if you wish to get a decimal approximation on the calculator, we'd get approximately 3.9. Problem 2b. First, we must isolate the exponential. So I suggest taking the negative 5 to the right side and writing 7e to the 2x. And adding 58 plus 5 will give us 63. Now to make the math easier, let's continue to isolate the exponential to get it by itself. So dividing both sides by 7 will give us e to the 2x equals 9. Now with the exponential isolated, we can use natural logs. And here, natural logs are chosen because we have base e. So the natural log of e to the 2x will be equal to the natural log of 9. Using the power property of logarithms, the power becomes the multiplier. 2x times log of e is equal to the log of 9. And the log of e is 1, so this gives us 2x is natural log of 9. And then dividing both sides by 2 gives us the value of x to be log of 9 over 2. And if we wish to get a decimal approximation, that's about 1.1. So let's go on to problem number 3. Now we have a logarithmic equation. And we want to isolate the logarithm and then we'll convert to exponential form. So we'll divide both sides by 4, giving us the natural log of 3x equals 8 divided by 4, or 2. And now we have the logarithm isolated. We'll convert to exponential form. The base of the natural log is e raised to the power 2 is equal to 3x. And then finally, isolating the x gives us e squared over 3 to be the value of x. Problem 3b. Now we have two logarithms. The idea is the same. We want to use log properties to get this down to a single logarithm, and once we have that single logarithm, we'll convert to exponential form. So here we have the sum of two logarithms, and we use the property that the sum of two logs is the log of the product. So we'll have the log of x times x minus 3, and that's equal to 1. Now we have a single logarithm. Let's clean up the inside here and make it the log of x squared minus 3x is equal to 1. Now, no base is written on the logarithm, so we know that is base 10. So we take 10 to the power 1 is equal to x squared minus 3x. So let's rearrange all the terms and get them on the same side. X squared minus 3x, bringing the 10 over to the other side makes it negative, and now we have the equation set equal to 0, and we can factor. If it factors, here it factors quite nicely, x plus 2 times x minus 5. Setting each factor equal to 0 gives us one possible solution of negative 2, and setting x minus 5 factor equal to 0 gives us another possible solution, x equals 5. Now, x equals negative 2 will not check. And the reason why is upon substitution into the logarithm, you will end up with the log of a negative number. And in fact, the other logarithm also ends up being a negative number inside the log. If either one of these occurs, the log of a negative number is not defined, so we must throw out this solution. And this one, if you try to substitute that in the given equation, you find that will also check.